This is an AS Further Statistics 1 question on chi-square tests, and this is on contingency tables. Abram carried out a survey of 2 treatments for a plant fungus. The contingency table below shows the results of a survey of a random sample of 125 plants with the fungus in this table here. Abram calculates the expected frequencies to carry out a suitable test. 7 of these are given in the partly completed table below, and that's this table here. The value of the sum of O minus E all squared, that's the observed minus the expected all squared, divided by E, the expected, for the 7 given values is 8.29. Test at the 2.5% level of significance whether or not there is an association between the treatment of the plants and their survival. State your hypothesis and conclusion clearly. Now I need to start with H0 and H1. Now I can get that information straight from the question, and it's this statement here. I'm testing to see whether or not there is an association between the treatment of the plants and their survival. Now whenever we write down H0 and H1 from a contingency table, H0 is going to be that there's no link or association, and H1 is going to be that there is a link or an association. So H0, there is no association between the treatment of the plant and their survival, literally taken straight from the question, and H1, there is an association between the treatment of the plant and their survival. The next thing I need to do is to calculate my test statistic using this data here. But the first thing I need to do is to work out what these 2 missing values are in the table. So to do that, I need the row total times by the column total from this table divided by the grand total. So for this box here, it's column total here, 15 plus 8 plus 7. I'll write down on the table. That's 30, so just write it down here. And then I want the row total for this box here, this cell, and that's going to be 56. What I'll do, because I haven't really got much space here, so my total is just going to be here, so 56. So this value here is going to be 30 times by 56, column total, row total, divided by the grand total, which we have here, which is 125. And if we do that, we get 13.44. Similarly, we're going to do the same for this cell here. So it's going to be this column total. Now the row total is still the same, 56. So it's going to be something times by 56 divided by 125. So let's work out what this column total is here. So this total here is 55. So I have 55 times by 56 divided by 125 gives us a value of 24.64. So 24.64. So now we can work out our test statistic, x squared. Now we've already got the sum of 7 of the values using this formula here. So that's 8.29. And then what I need to do is to continue to use the same formula, but for the remaining 2 cells. So I need to add to this the observed minus the expected, all squared, divided by the expected. So the observed here for this cell was 15. So it's going to be 15 minus 13.44. That's going to be all squared, divided by the expected, which is 13.44, and then do the same for this cell here. The observed was 16, so it's going to be 16 minus 24.64, and that's going to be squared, divided by the expected, which is the 24.64. Now this gives me a value of 11.50068 and so on. So 3 significant figures, we'll call that 11.5. We now need to look up our critical value, which means that we need to know what the number of degrees of freedom is. Now we have no expected values less than 5, so we don't need to combine any columns. So we take the number of rows minus 1 times by the number of columns minus 1. So that's just going to be 2 times 2, so we have 4 degrees of freedom. So I'll write down the 4 here. And it's a 2.5% level of significance. And we'll use the table to see what the critical value is. And that gives 11.143. Now remember, a chi-square test is always an upper tail test. So let me just draw out what this looks out here. So here's a typical chi-squared distribution shape, may not be exactly like that. And my critical value here is 11.143. So I reject H0 if my test statistic is greater than that. I'd accept H0 where it's less than that. It's greater than that. My test statistic is here, 11.5, in the rejection region. So that's telling me that I reject H0. And with any hypothesis test, you always need to write a conclusion. And we go back to what rejecting H0 would mean. And it's this statement here. So now we write our conclusion. Now, due to lack of space, I've shortened this down, but we write something like, there is evidence to suggest that there is no association between the treatment of the plants and their survival.